So we have looked at a few typical elementary work interactions, small work interactions, DW. Okay. A few things to note. First, in every case we have a system and we have a surrounding. The gas was the system, the piston was the surrounding. The liquid was the system, the stirrer was the surrounding. The electric cell was the system, the circuit of the cell phone was the surrounding. Second thing is to note that the final format of the work interaction turned out to be some plus or minus sign, some x into dy. This was the final format. P dv, E dq, tau d theta, T dl, everything was in the x dy format. Third, some sign convention was involved. In some cases we had a plus sign here, in a few cases we had a minus sign here. Then we should also know and note that often but not always x here is an intensive property of our system, whereas the second component dy, in which y is involved, y is an extensive property. So the work done is quite often but not always is represented by some intensive property multiplied by a change or a differential of an appropriate extensive property. This happens often but not always. And the fifth point to note is that some types, what we call modes of work interaction, are one way. We will look at the illustrations again to understand what we mean by this. Some other modes are two way. Let us go back to our illustrations and look at these points again. Let us look at this situation where our system was the gas in the cylinder piston arrangement. You will notice that the final format, which is P dv, P happens to be an intensive property, whereas volume happens to be an extensive property. So here the intensive extensive product exists. The sign here is plus, the system is gas, the surrounding is the piston. And here you will notice that initially when the piston is at rest with the force of the gas on the piston and the externally applied force in balance, no work is done. If the external force relaxes a bit, the piston will expand and the system will do work on the surroundings, the P dv product, because dv will be a positive number, volume will increase, dw will be positive, the system will do work on the surroundings. Whereas if the external force slightly increases, then the piston will move in compressing the gas, dx will be negative, volume will reduce, dv will be negative and dw will be a numerically negative quantity. So this is an example of a two-way work interaction. It is possible for the system to expand and do work on the piston. It is possible for the piston to move into the system, compressing the system, and hence the work done by the system will be negative. Let us come to the illustration of the liquid being stirred. Here you will notice that neither tau nor d theta are properties of the system. Properties of the system are not the torque does not exist unless we try to stir it. We just keep a liquid in a vessel, there is no torque involved, even if you just insert a stirrer and leave it there. So here tau and d theta are not properties of the system. So this is not included in what happens often. And now you will notice that if I insert a stirrer and try to rotate it, I have to overcome a torque, and hence my work done by the system is negative, minus tau d theta. But if I just keep the stirrer there and ask the liquid, hey Mr. Liquid, stir the stirrer, it won't do. So the negative of this does not exist. So this is an illustration of a one-way work mode. Come to the previous illustration, that of an electric cell. Okay. You buy a cell or you create a cell, it has a typical potential associated with it. A typical dry cell will have a potential of 1.5 volts, maybe different designs will have different. A Leclanché cell may be 1.2 volts. You can create various types of cells in your physical chemistry lab, the electrochemical experiments. Now many cells, particularly those in our laptops, mobiles, tablets, some torches, are rechargeable in the sense that they can discharge and work on a load. For example, it can drive our laptop or work our mobile, in which case the work done by our cell, the system, will be positive. The cell will be doing work on its surroundings, which is say the mobile phone. Whereas I can connect this to a charger to charge it, in which case the current will be in the opposite direction, but the direction of the potential will remain the same. So dq will be negative, E will be positive, so work done by the system will be negative. So if it is a rechargeable cell, charging and discharging is a two-way work mode, whereas if it is a non-rechargeable cell, a typical dry cell which you can buy, well, we cannot charge it, or we cannot charge it so easily. So that is a typical situation of a one-way work mode. I leave it to you as an exercise to discuss whether this spring being extended is a one-way work mode or a two-way work mode. Thank you.